from ChemPraxis, and today we'll be discussing IGCSE Chemistry Paper 6, Variant 2, May-June 2024. For the first question, when a mixture of calcium hydroxide and ammonium chloride is heated, ammonia gas is made. Ammonia gas is soluble in water and is toxic. Ammonia gas reacts with hot copper 2 oxide to make nitrogen. A student makes nitrogen using the apparatus shown in Figure 1.1. Name the items of the apparatus labeled A and B in Figure 1.1. For A, there are two answers in which you can put. The first answer will be a boiling tube, and the second answer will be a test tube. Both answers are correct, so pick one or the other. And for B is a measuring cylinder. For part B, it states that an apparatus needs to be heated in two places. On Figure 1.1, draw arrows in two places to show where the apparatus should be heated during the experiment. During the experiment, there are two places in which the apparatus should be heated in order for a reaction to occur. So, the reaction that needs to occur is ammonia needs to react with the copper 2 oxide. To do this, we'll heat calcium hydroxide and ammonium chloride, and the second part will heat the copper 2 oxide. This will allow both of these to react together, which will end up giving copper, water, and nitrogen, as stated. For part C, during the reaction, a colorless liquid collects at the point marked X in Figure 1.1. Suggest the identity of the colorless liquid. Over here, we can see that X is labeled in the first part, over here. So, when we heat calcium hydroxide and ammonium chloride, water forms. This water can be seen from this reaction here. Hence, the identity of the colorless liquid is water. Some of the ammonia gas passes over the copper 2 oxide without reacting. Suggest why none of this ammonia gas is collected in the item of apparatus labeled B in Figure 1.1. The ammonia will dissolve in the water, and hence, none of the ammonia gas will be collected. Part E states that the student does not collect the first few bubbles of gas. Suggest why the first few bubbles of gas are not collected because it is air. Explain why this experiment should be carried out in a fume cupboard. As stated from the question above, ammonia is toxic, and hence, this experiment should be carried out in a fume cupboard. For the second question, a student investigates the reaction between aqueous aluminum chloride and two aqueous solutions of sodium hydroxide, solution F and solution G. Solution F and solution G have different concentrations. The student does 3 experiments. Use the period diagrams in Figure 2.1, Figure 2.2, and Figure 2.3 to record the readings for experiments 1, 2, and 3 in Table 2.1 and complete the table. So from this Burack reading diagrams that were given, we can finish up Table 2.1. So for experiment 1, the final Burack reading, as stated here in the diagram of Figure 2.1, is 14.7. The initial Burack reading will be 1.3. And the volume of aqueous aluminum chloride added can be found by using 14.7 minus 1.3. Hence, we'll get 13.4. For experiment 2, the final Burack reading shown in Figure 2.2 is 29.5. The initial Burack reading is 2.7, and we'll use the final minus the initial Burack reading to get our volume of aqueous aluminum chloride, which is 26.8. And lastly, for experiment 3, the final Burack reading will be 28, and the initial Burack reading will be 0.4. We use 28 minus 0.4 to get 27.6. For part B, it states that in experiment 3, the aqueous sodium hydroxide in the conical flask is alkaline. At the end point, the mixture in the flask is no longer alkaline. State the color change seen at the end point in experiment 3. So going back to experiment 3, refill the burette with aqueous aluminum chloride. Run some of the aqueous aluminum chloride out of the burette so that the level of the aqueous aluminum chloride is on the burette scale. Record the initial burette reading and rinse the conical flask with distilled water. Use the measuring cylinder to pour 25 cm cube of solution G into the conical flask and add 5 drops of dimethylene indicator to the conical flask. Stand the conical flask on a white tile and slowly add aqueous aluminum chloride from the burette to the conical flask while swirling the flask until the dimethylene indicator changes color. So this color change will go from blue to colorless. Dimethylene will appear colorless as an acid and only shows blue when it's an alkali. Hence, if the mixture in the flask is no longer an alkaline, it will turn colorless. State why the conical flask is swirled as solution F is added in experiment 1. The conical flask is swirled in order to mix the reactants together. Suggest why the conical flask is placed on a black or colored paper in experiments 1 and 2. So going back to experiments 1 and 2, rinse the burette with distilled water and then with aqueous aluminum chloride. Rinse the conical flask with distilled water. Fill the burette with aqueous aluminum chloride. Run some of the aqueous aluminum chloride out of the burette so that the level of the aqueous aluminum chloride is on the burette scale. Record the initial reading. Use a measuring cylinder to pour 25 cm cube of solution F into the conical flask. Stand the conical flask on a black or dark colored sheet of paper. Slowly add aqueous aluminum chloride from the burette to the conical flask while swirling the flask until the mixture in the conical flask just starts to become cloudy. So the same concept applies in experiment 2, where we slowly add aqueous aluminum chloride from the burette to the conical flask while swirling the flask until the mixture in the conical flask just starts to become cloudy as well. Hence, the conical flask is placed on a black or dark colored paper in experiments 1 and 2 to be able to see the white precipitate better. When it starts to become cloudy, having a dark colored background will allow us to easily observe the white precipitate. For part E, there are 2 parts. Firstly, explain why the measuring cylinder is rinsed between experiment 1 and experiment 2. The measuring cylinder is rinsed in order to clean the measuring cylinder. In part 2, explain why the measuring cylinder does not need rinsing between experiment 2 and experiment 3. In both experiments, only solution G is used, hence we will not have to rinse the measuring cylinder at all. Next, compare the concentration of solution F used in experiment 1 with the concentration of solution G used in experiment 2. Solution G is much more concentrated as a larger volume of aluminum chloride is needed in experiment 2. It is a quantitative relationship wherein twice as concentrated is required. Calculate the volume of aqueous aluminum chloride required when experiment 1 is carried out with 10 cm cube of aqueous sodium hydroxide instead of 25 cm cube. The volume of aqueous aluminum chloride required when experiment 1 is carried out with 10 cm cube of aqueous sodium hydroxide will be 5.36 centimeters cube. In all 3 experiments, it is more accurate to measure the volume of the aqueous sodium hydroxide using a volumetric pipette instead of a measuring cylinder. Explain why it is not possible to use a volumetric pipette to measure the volume of aqueous aluminum chloride in these experiments. The volume used is not the same in each experiment, hence it is not possible for us to use the volumetric pipette, and instead we use a measuring cylinder. In question 3, a student tests 2 substances, solid H and solution I. Solid H is a barium carbonate. Complete the expected observations. The student adds an excess of dilute nitric acid to the sample of solid H in a boiling tube and tests any gas produced. The lime water turns milky and effervescence occurs. What is the gas made in part A of Part 1. The gas made is carbon dioxide as the lime water turns milky. Lime water only turns milky when carbon dioxide is present, and hence your answer is carbon dioxide. The solution produced in Part A, Part 1 is solution J. A student divides solution J into 4 approximately equal portions. The student carries out a flame test on the first portion of solution J. You will observe a pale green flame as barium is present. To the second portion of solution J, the student adds a few drops of acidified aqueous potassium manganate. The solution turns pale purple as potassium is present. To the third portion of solution J, the student adds a few drops of dilute sulfuric acid. We'll observe a white precipitate form. To the fourth portion of solution J, the student adds about a 1 cm depth of dilute nitric acid, followed by a few drops of aqueous barium nitrate. We'll observe no changes happen here. Table 3.1 shows the tests and the student's observations for solution I. The student divides solution I into two portions. Identify the gas produced in test 1. In test 1, to the first portion of solution I in a boiling tube, add 2 cm cube of aqueous sodium hydroxide and warm the mixture. Test any gas produced using a damp red litmus paper. The damp red litmus paper turns blue, and hence we can conclude that the gas produced in test 1 will be ammonia gas. State what is observed when the gas produced in test 1 is tested using damp blue litmus paper. The damp blue litmus paper will have no changes and it will stay blue. Identify solution I. So we can identify solution I by looking at the results of test 2. To the second portion of solution I in a boiling tube, add 1 cm cube of dilute nitric acid followed by a few drops of aqueous nitrate. A white precipitate forms. So using these observations, we can conclude that solution I is ammonium chloride. And for the last question, bismuth is a metal that has a reactivity similar to that of copper. The ore bismuth contains the compound bismuth 3 oxide. Bismuth 3 oxide is insoluble in water and reacts with dilute acids to form an aqueous solution of a salt. The ore bismuth contains no other compounds that are insoluble in water and no other compounds that react with acids to form aqueous solutions. Describe how you could obtain a sample of bismuth metal starting with a large lump of the ore bismuth. You have access to common lab apparatus and chemicals. So there are multiple methods in which you can obtain bismuth. However, this is the method I've gone with. So for the first step of the method I've chosen, crush the ore into a powder using a pestle and mortar. Ensure you state what you're using to crush the ore. Step 2, add water and filter it. Step 3, add a more reactive element to the residue like zinc. Next, heat the ore, which will form bismuth. And lastly, the bismuth will form by displacement. So you want to state how the bismuth form and what you can do to create bismuth. Ensure that your final answer is in paragraph 4. Here are the other methods listed from the marking scheme of this paper.